sucks. Got another F. AP Chem is kicking my butt. Especially acid-base equilibrium.
Hello, AP Chem students!
What are you doing in my house?
Has
this ever happened to you?
Having trouble keeping up in your AP Chemistry class? Finding it hard to turn in your homework on time? Struggling to understand even the most basic of chem concepts like a total idiot? Are you a real moron? Stupid dummy boy? Fool?
Who are you talking to?
Have we got the solution for you? Our acid-base equilibrium and solubility study guide will be the catalyst of your future success. These tried and true study materials feature equilibrium, pH, how to find pH of strong acids and bases, the icebox, conjugate acids and bases, buffers, neutralization, KSP equation, solubility, and even the exclusive rice box. Now here's our two AP Chem students. One who's used our patented study guide and is doing absolutely fantastic. I mean, look at those grades! And the other student, on the other hand, has not used our study guide. And look at those grades.
Point number 1 is the equilibrium of acid-base solutions and solubility. Equilibrium is dynamic, meaning that it never stops reacting. When the forward and reverse reaction rates of reaction is equal, it means the total reaction has hit equilibrium. So, have you understood so far?
No, wait.
Too bad! We're gonna move on to point number 2, pH.
Point number 2, pH. pH is the measure of hydronium ions in a solution, and it can be either acidic or basic. If the pH is less than 7, it's acidic, and that's spicy. But if the solution is 7 to 14, that's basic, and you know what that is? Ooh, it's strong. Fun fact, very strong acids and bases can give you horrifying chemical burns.
Point number 3. Finding the pH is easy for strong acids and bases. The 7 strong acids and 8 strong bases all share something in common that makes this process as easy as can be. When put in water, they ionize or break apart completely. That means that the concentration of the acid is equivalent to the concentration of the hydronium ions. Then use this wonderful formula, so graciously provided by us, to calculate the pH of acids or bases. Watch our model chem student use our formula to calculate pH in this next clip.
I'll use this formula to find the pH of 0.1 molar hydrochloric acid. So, pH is the negative log of H plus. Now in a strong acid like hydrochloric acid, 0.1 molar HCl is equal to 0.1 molar H plus. So pH equals negative log of 0.1. pH is equal to 1. Wow, it works so well.
Point number 4, the icebox. Here's how it works.
So here's how it works. You take these values and you put them in your icebox. Values in. In just a few seconds, you'll get an answer. And it even comes with all the math involved.
Point number 5, conjugate acids and bases. In the Bronsted-Lowry acid-base theory, this is the compound after the acid is ionized, or after the base has gained its electron. Strong acids make weak conjugate bases, and weak acids make strong conjugate bases. And the inverse is true for bases. Part number 6, how buffers work. Buffers are the conjugate ions of the acid or base. When added to the acid or base, it's going to buffer. It lowers the strength of the acid or base, lowering the change in pH. Buffers are everywhere, even in our blood. Without buffers, our blood might become too acidic or basic, ultimately killing us. The formula for finding the pH of a buffer solution is this.
Point 7, neutralization. An acid and a base react to form water and a salt. These reactions involve H plus ions and OH minus ions to make water. When something's neutralized, it means an acid and base that form a salt. Fun fact, strong acids can be neutralized with strong bases, and it's a super handy trick to know in the lab. Super sick.
You're kidding, right? That's horribly dangerous. You can't sell this product. That's not what happens. So what actually happens can be seen through a graph like this. Instead of neutralizing at a pH of 7, as it gains more neutralization, it actually jumps and then becomes the inverse of what it was. If it was an acid, it'll become a base, and it's still super deadly. So as you can see, it's really not a neutralization, and this is super horrible idea. You can't actually sell this. I don't endorse this. Wait, where are you going? You can't sell this product. Stop.
What does that chemist know anyway? Let's move on.
Moving away from acid-base equilibrium, we move on to point number 8, solubility. Separate from acids and bases, it follows the same concept of equilibrium. When solutes dissolve into solvents, there's only so much a solution can hold before it becomes saturated and can no longer hold any more solutes, if the solutes no longer dissolve it. The equilibrium part is the reaction between the decomposition of the solute into ions and the formation of the solute via those ions. Point number 9. KSP equations. KSP, or the solubility product constant, is a part of solubility equilibrium. This number measures the amount of solute that can dissolve in the solution. The higher the number, the more it will dissolve. In order to find KSP, we created another formula derived from the equilibrium formula shown earlier. We have point number 10 for limited time. The rice box, now with ratios. Now here's how it works.
So here's how it works. You take these values and you put them in your rice box. Values in. Wait a couple seconds. Answer out. And it even comes with all the work. So now do you get it?
After seeing the benefits of our top-notch study guide, what's to wait for? Call now 1-800-SCAN and pay with 14 payments of $100 each, or even lower of 7 payments of $300 each.
And the first 20 callers will even receive our additional included problem-solving solution for free. What's to wait for? Call now!